Hi there, and a very warm welcome to this week's video in which we are learning yet another 3D software which is called Plasticity and is a computer-aided design modeler. And what we are going to do, I have on my arm, and it's this wristwatch here. And this time we are modeling the case, and in next video we are modeling the crown and the watch face. And after that we are exporting it into Cinema 4D and then shading that. So without further ado, let's strap up and get right going. Or something like that. Welcome to the What's Up section, where I go over what's new this week in my life. You might have just spotted it in the background of the video. I finally managed to get my prints and I hanged them on the wall behind me. I'm really satisfied how this came together and how this improves my office space, as it gives it a nice, cozy yet professional feeling. Other than that, I worked on some client projects this week, so there's not much to tell. And with this, let's jump into the plasticity bit. With this out of our way, let's have a quick look what plasticity is and what differentiates it from, for example, Cinema 4D or Blender. So while Cinema 4D and Blender are based on polygons, plasticity is a CAD program or computer-aided design. A good analogy here is a pixel-based program like Photoshop, with its pixels being compared to the polygons, in contrast to a vector-based program like Illustrator, where you are not relying on pixels but on mathematical functions to get you basically infinitely high resolution. So while Blender and Cinema 4D are mostly used for creative purposes, CAD modelers can be used in production to actually produce the objects you'd have designed and mass produce them later. Though I would categorize plasticity somewhere in between, as this has a bridge to the traditional polygon modeling in its handling, but isn't very production oriented, as it still caters to creatives rather than to engineers and therefore to the production side of things. Before we finally dive in, let's talk about why plasticity. There are 3 reasons. First of all, I already mentioned that it is artist-driven and not engineer-driven, and well, I'm an artist and not an engineer, so that fits very well. The next point here is that CAD modeling can be quite a bit faster than SDS modeling, and while I love SDS modeling, in some cases I just need to be fast. And the last point here is pricing. While it costs money and is not for free as Blender, it is rather cheap. You can see the indie license, which I have, costs $150, and the studio license here costs only $300. And despite its looks, it's not a subscription. Within the dollar range, you are getting 12 months of free updates, and then you stay with this version if you don't want to pay further. Alright, this is all set now, at least I think so. So let's jump in. And finally, welcome to Plasticity Land. Now, this is the 2025 version, so 25.1, which has a revamped interface, so if you worked with it before, you might see that it looks a little bit different. As the interface of Plasticity is rather simple to learn, I'm going for a learning by doing approach. While modeling, you will see me invoke commands and where I click, and therefore understand the interface more and more. One thing I need to set up beforehand though, as I'm coming from Cinema 4D, I want to have the Cinema 4D navigation, therefore go to Preferences, and the first tab actually is the navigation here, and we are going to invoke the Maya navigation as there is no dedicated Cinema 4D option. This will just change the navigation from the default Plasticity one to the Maya one, which is the old navigation as I know that from Cinema 4D. Next, your scene scale might be set up to be a little bit larger. This is very easy to change. You just can set the grid size here, and as we are modeling a watch, this should be rather small. If I go to the top menu and hit New File and then say yes, you can see that I set up my scene to be this small scale here. If you want to do so too, you can set up any scene and then save it here under Save Startup Scene, and then it will pop up whenever you do a new scene, as I did. Alright, so let's start. If you want to rebuild objects like I do with my watch, I recommend you to have a caliper and measure stuff, since this is a construction program to start with and therefore a step closer to the engineering world, where measured data is a little bit more important than if you're freestyling stuff. So let's start with the same thing than we do in Blender most of the time, by deleting the cube. To bring in our measured data from the watch face, there are multiple methods we can do, but I want to concentrate on curves right now. You can think of them as paths as in Illustrator terms. The good thing of a watch is that it mostly consists of circles, so let's go to the center circle and then drag it out here. As I measured with my caliper, I know exactly how big those need to be. To get in the value here, you can hit Tab and then type in the value. For example, the first value would be 25, and then hit Enter. Since we don't really need perspective view right now, we can go to our navigation cube and click on its top to get to top view. Of course, there are also shortcuts for this, and Blender uses rejoice. A lot of them are similar than in Blender. So, for example, for the views, you can use your numpad by clicking on 1, 7 and 3, and therefore get to the different views. Let's go to 7 again, which is the top view, zoom a little bit in and add some more circles. We could use the same option again and center circle, but since I want you to learn something, we just duplicate this active circle here by hitting Shift D, and you can see now there are 2. This gives us the option to move it, but we want it to be at the same place, so just hit OK or Enter. To change its size, like in every other 3D program, we could scale it by hitting S and then scale it up, for example, but this makes it very hard to get exact measurements. So let's cancel out and instead find another command, find like F. So what we can do here is go with the dimension. And if we invoke that, we can just type in the new measurement, which should be 38. Here we go. Let's go into shortcuts real quick. The shortcut for measurement is the equal sign on your keyboard. Since I have a German keyboard, this is not the case, so I needed to make my own shortcut. If I hit F again and then go to dimension, you can see I have my own shortcut here, which you can set here. You can also add this to your favorites, which I already have. So if I go outside of the menu and hit F again, you can see this is the dimension tool that we just talked about. And also I have the measurement tool as my favorite as well. Alright, let's add some more circles. Let's use the center circle command again, but with one trick. In the grid menu here, you can toggle the snap to grid, so you don't have to press Tab to get the exact measurements, so 40 for this one. If you're looking for more or less granularity in your snapping, this is also not a problem. You can change that here. For example, 10 times the resolution with 0.1 millimeters. So if we invoke the same center circle command again, you can see now our steps are much more fine. What we are searching though is the answer of the universe, which is well known to be 42. Here we go. The last circle is the outer radius of the watch, so rather big. Hit Tab and then 57. Alright, those are all circles for now. Let's change the shape to a rectangle to get those standoffs working that hold the wristband. If you hold down the mouse longer on the rectangle, we can see more options, and we want to go with the center rectangle here. Let's grow it out from the center, then hit Tab, 65, and since we have a dimension more, we hit Tab again, 22. Since we need 2 of those rectangles, let's duplicate it by Shift D, hit Enter, and then invoke the dimension command, so F, and we can go to the shortcut here, and instead of 22, we want to have 29. Here we go. If you don't know where this is going, I promise you this will make sense in a couple of steps. So let's do those steps and invoke the line tool and go from the intersection here to the outer rectangle and then hit Enter to confirm. Next, what I want to do is go to the control point curve. Here we go. And then go from this point to the point we just created and then to the outer circle. If we go near it, you can see there's a point appearing, which is the tangent point. So click on that and then hit Enter. And now you might be able to see we just created the arm for the holder of the wristband. If you're still having problems recognizing it, we can mirror it to the other sides. So let's make sure it's active. and then hold down Alt X. And this is the mirror command. Let's go with this axis, hit enter, then go with both of those, Alt X, and then the Y axis here also. Here we go. This makes the watch face here complete. Now we have to do additional modeling steps to make it from a flat piece of paper into an actual watch. You might have noticed the highlighting underneath our mouse cursor, and this is because those sections are selectable and then extrudable. Now we can even shift click and select multiple of those and then extrude them into one single piece. And we need to do that with our watch here. As selecting all the sections one by one is a little bit tedious, we can select all of them together and then deselect just those that we don't need. Like this. Now if we extrude, we have a small problem in that all the lines are extruded as well, which we don't want. And this is where the selection menu comes into play, where we can choose what we need to select. So either by clicking or shift clicking for multiples, or with your keyboard number row 1, 2, 3, 4. So what we can do is press 3 to only select the faces, do all of that again, and now we can see none of those edges have been selected, and then deselect everything like this again. Here we go, and then extrude it. Let's go with a height of 15 millimeters for now, and you can see our watch now is taking shape. Now our watch looks like a watch from the top, but very blocky from the side. So let's make it look like a watch from the side as well. As I said before, the really cool part about this watch is that it's made of circles. So let's go for a 3D circle, a sphere from the side, and drag it out from the middle. Now you can see it will bool away the object. This is not our intent. But down in the lower right corner you can see some shortcuts, including new body, which is B. So let's press this, then hit tab and type 120, hit enter twice, and this is our sphere. What I want to do next is move down the sphere so it intersects with the topmost part of our watch face. To do so, let's zoom out a bit, then hit G to move it. Before we drag, let's change the snap to grid radius to a larger scale, and 1 millimeter seems to be okay, and drag it down so the top part of the sphere is roughly the same height as the watch, which in our case is -45 millimeters. Hit enter to confirm, go to object mode here, shift click on the watch, and then we want to engage in a Boolean operation, which the shortcut is Q. We are in difference mode right now, and for this the selection order is important. So the watch that was selected second is now booled out of the sphere, which was selected first. But we are not interested in difference mode, we are interested in intersection mode. So this one here, let's hit enter, and now you can see we have a nice spherical watch top. I want to roughly do the same for the bottom part of the watch, but roughly only. Because if we go through the same procedure here, let's drag this down just a little bit further, so 51 millimeters. And then we are actually going to select the watch first and then the sphere and then hit Q. So the bool is subtracted from the watch. If we now confirm this and go into 3D view, you can see this is not the exact behavior that we are after because it cuts into the places where the movement should be later. So what we're going to do is a little bit more complicated, but also in the realm of circles again, because this watch, I say it again, is full of circles. So what we are going to do in the intersection of this feet here is going to go with a reverse circle. So let's go into side view yet again and do this. Of course, undo what we did here before. So we are back to square one. To construct this, I want to go into curves realm one more time with a center circle out of the middle here. And again, 120. Here we go. Zoom out a little bit and create a couple of lines. One through the center here. So just make that intersect. Here we go. Enter. Duplicate the line by Shift D. And now we can use the move tool to move it to the side 21 units. Remember the 42 circle. So this is just the radius of it. So we end exactly at the same border. Now confirm and then select the circle here. Oh, this is not possible because we are not in line mode. So let's go there, select the circle, hit Shift D to duplicate. Now what we want to do is set our pivot to the intersection between those both lines and then move it to the intersection here. And we can see we have a pivot mode here. So what we need to do is hit V and then move the pivot to the intersection point and then start moving up. This is not matching here. So what you can do is hit Control and this then snaps to other intersections. Here we go. And then hit enter and now we have made an inflection point of our circle. Now a lot of lines are going on here and we only need the intersection here. So there's a neat command for that, which is trim and the T shortcut. So once you've hit T, you can trim out parts of the object that you don't need, something like this. And then what we want to do is enter and select those outer parts and revolve them around the center. For that, let's dive into a menu that we haven't seen before. Those are the most used functions of Plasticity, at least according to Plasticity, and I tend to agree. So what we want to do is go to Revolve and then select the axis at which we want to revolve around. Here we go. And now we have a sort of circle with a dent in it. Let's confirm. And what is this? We have new objects that are called sheets. So a sheet is basically just that, a non-volumetric object. So the body doesn't have a thickness. To convert them to a solid, what we can do in object mode, select both of them. And if they're touching, we can join them by hitting J. You can see this converts them into one solid. Let's move the sphere to the right place by hitting G. Like in Blender, we can just use the keyboard for that. So let's select an axis C. And then we can type in -51 and then enter. And now we can bool. As we want to subtract the sphere from the watch, we need to select the watch first, then the sphere, then hit Q, and then enter. Here we go. Now we see that we have the right look of our bottom. Well, sort of. I say sort of because the slope only continues, of course, till we reach the backside of the watch that is screwed in. So let's take care of this next by going to the top view, the 7 on the numpad. Then what we can do is select the inner circle here. For that, we need to hit Shift and Edge mode and then select this edge here with the 40mm diameter. Then Shift select our watch solid as well, and this is a new command. If we now hit C, we cut the solid by the curve. Here we go. So what we have here now is a outer and a inner watch part. What I want to do is go with the inner for now and select the down face here. So let's go into face mode, shift click on that. And then first you go into object mode. And once the object is active, we can select faces. So this one here. Other than in polygon modelers, just deleting it will not work. So what we need to do here is go with Shift X instead, which is the delete command for faces inside of Plasticity. You can see as soon as we do that, we have a sheet again because it's not a volume anymore. So what we want to do is instead of a spherical shape here, we want to just have a straight plane. And this is also very easy to do. What we need to do is select the rim edge, then go to our default menu options here again and set patch. It's Shift J, but let's go with the menu for now. And now we see we have patched this hole. And if we hit return, we are back to a solid, but with a flat bottom part. Let's actually get rid of our curves because they're going on my nerves. Unintentional rhyme again. Well, sort of unintentional. We could turn them off via the curves layer, but this then would not show new curves if we need them. So I'm just going to select all of them and toggle the I button. Here we go. If I turn the outer watch piece back on for a second, you can see what we have done here. As this is all part of the watch now, I want to create an extra piece for the backside. What we can do for this is select the back piece again. And while it's selected, we can actually duplicate that by Shift D to create another sheet. So since this has been duplicated, the original watch face here is untouched. And since this is a new sheet, we can use a new command on it, which is thicken. And we want to thicken it by 2 mm. and enter to confirm. Here we go. Now, if we leave it like this, this will be highly uncomfortable to wear. So let's select the edge, and the really good part of that is if we select an edge, the fillet tool is already invoked. This tool is basically 2-in-1, so if I drag it inwards, we chamfer, and if I drag it outwards, we fillet. We want to chamfer here, but right now we are chamfer symmetrically, taking away 1 millimeter from each side. What we want to do is make this unsymmetric by ticking off this toggle here and going with 1.5 on one side and whole 4 millimeters on the other. This looks much more comfortable now. Let's next create those indents for the watchmaker's tooling to open the backside. To do this, I want to select the edge and then Shift D duplicate it into a curve. That also works. So faces become sheets, edges become curves. So confirm, then F, and what we want to do is get measurements here. And instead of 30, we want to go with 35. Here we go. To create those sprockets, let's go with a center rectangle. We want to create that on the same height as our circle spline. This seems to be the one, and then drag it out quite far. Better safe than sorry, 2x48 seems to be fine. Let's select this section here and extrude it, and we can hold down Ctrl to extrude it to the level of the lower lip here. Let's turn the camera so you can see what we did. Here we go. And this is okay. Let's confirm and then do something new again. So while this piece is still selected, we want to go into Radial Array mode, this one here. And now what we need to do is select a center, something like this, and then get for the number and see if that looks alright. So let's go to the top view. And actually that's too much. We need 2 less. So instead of 8, we are going with 6. Here we go. Let's confirm and turn off those curves so they are not in our way. And then you probably know what's coming. We select this first and then select all the other parts afterwards and then hit Q and enter. Now that we've done that, I see that those probably have to go inward a little bit more. So what I'm going to do is go to face mode and select all of those. So the really cool part here, since all of those surfaces are mathematically defined, we can just do stuff like this. While we are at it, I think I have over and underdone it in some other parts. So for example, this back face is too far away. So what we can do is also get this right. Now this is too far. So what we can do is go to our snapping and make it smaller again and then go for 0.3. I think I more likely opt for 0.25 here. And as a last step for the backside for now, I want to also select all of those. And widen them 0.25, so they are just a little bit more square. Something like this. And here we go. Now that we've done the bottom, let's take care of the top side of the watch. Let's go into top view and make some more cuts. To do that, let's go into edge and solid mode. Then select the 40mm circle, make it visible. Shift select the outer watch part and then hit C one more time to cut and enter to confirm. Then find the curve we just made for the backside, turn it on, change its diameter to be 36, and then also cut the inner part here with it. Here we go. So the inner part is actually something we only need one piece of, and this is the top for the glass later on. Let's also add the face mode and then get this and Shift D to duplicate it into a sheet, and then we can delete the rest of the inner bit here. Let's turn off the glass sheet for now. What this is all about is that our watch has a small bezel between the case and the glass, and this is those two parts here, which I want to unionize. To do so, let's hit Q 2 times. This is a Boolean operation, and if we confirm, you can see those are no one part. Also, the bezel is slightly elevated, so let's select the face and then go with an elevation of 0.5 for example. Here we go. Let's turn back on the glass sheet here, and we notice that it is not elevated with the rest, so let's grab it, G set 0.5. Also, if we go to side view, the side view, here we go, and compare it with our watch, the diameter of the glass here is double the size, so it's flatter. Since this is a sheet, we can actually scale it. So let's confirm the movement first, then hit S for scale. We want to scale it on the Z axis by 0.5, but now you can see that it's moved from the bottom. To avoid that, what we can do is go for our pivot again. So V, then move the pivot here, and then scale it 0.5. Here we go. Let's give this glass some thickness, as this is needed to make it render realistic. And while doing so, introduce you to a new command. So if we select the glass, we can solo it by hitting the dot key, but not as in Blender on the numpad, but on your keyboard. If you think Thicken tool, good call, but unfortunately, since this is part of a sphere, it is tapered. This is not what we want, and I'm not sure if there's another way. Let's do it the brute force way. So let's duplicate the sheet by Shift D, then move it down maybe 1.5 millimeters. This seems to be a right thickness for glass. So what we want to do is Shift select both of those objects and then Shift select those edges here. If the edges don't go all the way through, we can hold down Alt and Shift, and basically this is a loop selection. And then to join those together, new command incoming, we are going with a loft. If we go into side view, we can see something interesting, and this is we have an interpolation here. You can toggle between them with the tab key. G3 is not possible yet. It's a bit hard to explain, but this is maybe something for another tutorial. Let's hit tab one more time to go to G0, which is non-interpolated or linear, then hit enter to confirm. And now this is a perfect time to show you something that might slip under the radar as a inconsistency while we are selecting. So if we selecting to the left side, everything the selection touches will be completely selected. If you are selecting to the right side, nothing is selected unless it is inside the bounds of the selection completely. This is a little bit like tolerant selection in Cinema 4D, but built in the gestures of one tool, which is very elegant. At least if you know, otherwise you might be confused about the selection behavior sometimes. Back to Plasticity, let's bring this project home by hitting J and joining all of those objects together. Then hit the dot on your keyboard to exit solo mode. And the last thing I want to do here is bevel those edges here from the holders, as those are a little bit rounded in reality. I of course tried this before, and I think a value of 4 might be a good fit. So let's type in 4 and hit enter. And this is it for this time. I hope you enjoyed it. As I said in the beginning, we are going to take care of the rest of the watch next session. If you want to marvel at your creation, what we can do is go to the shader mode and choose another matte cap, and also get rid of the show edges, and therefore you can see the object in its full glory. Now you might wonder why there's no filleted edges on there. The reason is rather simple. Modeling operations, as we did in the backside here, wouldn't be possible if we had rounded those edges before. So the most valid workflow for me is to finalize the object completely, then duplicate it, and then have a version with filleted edges. Now, if you like my videos and the work I'm putting into those, then consider joining me on Patreon. I would be delighted seeing you there. Speaking of Patrons, let's thank those people who made this video possible, my already existing Patreons. Especially my €50 tier subscribers, Shields Augustinen and Leon Studio TV. Also, of course, a huge thank you for my €15 tier subscribers, Doyim, For the Thieves, Render King Alessandro Bonchio, Alessio De Vecchi, Ami Shitreed, Antonio Abibe, BVR, Christian Grajewski, Erbe Plus Akademie, Eva Nilsson Tavares, Joel Mackimer, John Edward, Chris Clemson, Ness Graphics, Nico Straub, Part 1 of 2, Ralph, Reiko, Reshock, Shamus Johnson, Shiro 2049, Terry Wayne Ranson, and Yassin Rupp. Hello to everyone who's joining in at the end of the video. Night Owl Raphael here. This, for some reason, is the most intensive video I've ever worked on, at least when it comes to tutorials. It's roughly 5:30 AM and I thought I would be finished before 12. So right now I'm both a night owl and a early bird, I would say. Let's hope there is a worm for me somewhere. Because of this late timing, I'm making it short today, so if you want to support me against the algorithm overlords, post a watch or some sort of clock in the comments down below. I thank you very much. I hope I can bring this tutorial actually out for Monday, so hopefully a great start into the week to you, or if you were watching this later, a fantastic time. As I usually always do, I wanted to do something smart with the word time. But it's really too late for today. I've been awake for more than 24 hours now. So the only thing I will say now is bye.